Hello, I'm Stewart Wuest, and I have studied factors influencing water for cropping systems in the dryland Pacific Northwest for the past 25 years. Today I will summarize a recent study I performed with Bill Schillinger to find out how much flexibility we have in timing the first tillage pass in a tilled summer fallow system. For viewers not familiar with the 2-year winter wheat summer fallow system practiced in the driest areas of the inland Pacific Northwest, the goal is to get the wheat to emerge and start growing before the weather turns cold. In these dry areas, there is almost no chance of significant rain from July to mid-October, so the wheat is seeded very deep into moisture protected by a loose soil mulch. This photo shows wheat emerging at the end of a very dry summer. This system produces good yields where rainfall is 6 to 14 inches a year, and very few other crops are sustainable. Farmers have made tremendous progress in reducing or eliminating soil erosion. We used to deal with last year's crop residue using a plow as just the first of many tillage operations to produce a fine seed bed. This is one brand of undercutter sweep that kills weeds and creates a soil mulch without inverting the soil. This leaves residue and soil organic matter on the surface, where it improves water infiltration and resists erosion by wind and water. Depending on the soil type and soil moisture, one pass can last the rest of the summer if we don't get a late flush of weeds. Where winters are mild, no-till fallow can perform well because fall rain penetrates more effectively and there is still enough warmth for the wheat to put down roots before cold weather. At higher altitudes and higher latitudes, fall and winter are too cold to get good root establishment if the wheat does not germinate before October. On to the recent results. Our goal was to compare early, average, and late initial tillage dates, measuring the total stored root zone water and also seed zone moisture. We used just one tillage pass, because previous research has demonstrated that careful use of an undercutter in a weed-free fallow does not require rod weeding to maximize seed zone water. Early tillage was needed decades ago to eliminate residue and weeds. Residue plugged standard drills, and weeds use water. We can now maintain weed-free fields with herbicides, and improved seed drills allow the benefits of surface residue without plugging. Benefits include erosion protection, water infiltration, less crusting, reduction in evaporation, less diesel, better tilth, and drought resistance. How long can we wait for the first tillage? Does significant evaporation start as soon as it warms up in April or May? Do April, May, and June rains contribute to soil water? Advantages to delayed tillage are reducing the number of tillage passes needed to stay weed-free the rest of the summer, and a better chance when it is hot and dry of killing escapes and tough-to-kill weeds. Less tillage means more residue, which means more soil water after every rain up until canopy closure. Untilled soil absorbs water faster and deeper than tilled soil, roughly in proportion to how severely it has been pulverized. So, to maximize soil water in the root zone, we don't want to till before all the rain is finished. Of course, predicting when the last significant rain has occurred is a problem. I had quite a bit of data from small plots showing surprisingly little evaporation in the first half of summer. This experiment looks at early, normal, and very late tillage on weed-free summer fallow. If you're interested in the details of the experiment, you can pause on this page. For now, I'm going to jump into the results. Here's how to read the data. The graph shows soil water in September. At Lynn, in 2018, shown here, we tilled 4 of the plots in late April. At seeding time in September, there was about an inch of soil water to a 10-inch depth, and a little over 2 inches to a 20-inch depth, and about 6 inches of water to a 50-inch depth. Now, the black bars are rain. So we had about an inch and a half of rain between the first tillage and the second tillage. We tilled 4 more plots. This was the second tillage timing, which happened to be mid-May. You can see the stored soil water in September was very similar to the first tillage at the shallow depths, but some of that rain was stored at the deeper depths. So it looks like the mid-May tillage, in this case, when it was very dry the rest of the summer, maximized water storage. Now, note that the last points in each line were no-till plots. So these were never tilled. And all these samples, all these points represent soil samples taken on this same day in September. I guess it was almost September. And keep in mind that weeds were controlled with a hoe or herbicides the entire summer. There was only 1 tillage pass per plot. Here are all the sites and years. There's a lot of data in this graph, but what I noticed is that there are not any cases where lots of soil water was lost due to late tillage. This fits with years of data comparing no-till to traditional tillage fallow, and finding that the total stored water is usually comparable. Also notice that when deep water is lacking, like at Echo and Lind in 2014, none of the tillage timings produced better soil water at a 10-inch depth. It takes water from below to maintain seed zone moisture. Looking at all sites and years, mid-May or June was often as good or better than the earliest timing. You might want to pause or come back to this and see what your own conclusions are. I know some of you are saying, Stewart is crazy. I know I lose moisture if I don't create a soil mulch. Now we are looking at soil moisture near the surface at 6, 8, 10, and 12 inches. This is where we see the soil dry in July and August. The points are the moisture level at a particular depth, a point measurement, not the average of, say, 0 to 6 inches. Keep in mind that all the measurements were made on the same day in September. So any substantial rain that fell before sampling affected all the treatments. 2014, for example, there's some rainfall and the no-till looked pretty good and the levels came up. And that's what's true in Echo. It's usually true in Morrow and Lind also, although less rain in Lind. I'll also point out that Echo and Lind in 2014 were especially dry, even at 10 and 12 inches. So there's Echo 2014. This is a pretty low level for 12 inches. And the same down here. And remember, these are the places where the subsoil was very dry. You can see how water from rainfall events was captured by plots that were tilled after a rain, but not by plots tilled before a rain. So here's a rainfall, and the early tillage didn't collect that rain and store it till September. And here the moisture comes up following these rainfalls. These have not been tilled previous to the rainfall. So the earliest tillage timings produced often close to the best results in some cases, but in general, May and June timings were better. In summary, evaporation from our soils is limited and slow in the early summer. Creating a soil mulch decreases the evaporation from the surface, as measured in September. The soil mulch also stops infiltration of subsequent rain. On average, the soil-water trade-off may be negative starting in late June most years at the locations tested. And of course, it would be easier if we could predict the weather 2 months ahead.